In this episode of Scaling Postgres, we talk about data skew, monitoring, remote access CSV, and documentation. I'm Preston Jameson, and this is Scaling Postgres, episode 270. All right, I hope you, your friends, family, and coworkers continue to do well. Our first piece of content is data skews in Postgres. This is from crunchydata.com. And by data skew, they're talking about the distribution of your data is not in a normal distribution or a bell curve. You have certain bits of data that are highly overrepresented. So maybe this is a large account in your software as a service application, and it makes up the majority of your data in a table compared to other customers, for example. Now they have an example here of where they're showing a distribution where all the data points for a particular day amounts to 30%. So here the data is skewed to this particular day. Now as a consequence of it, Postgres, once it gets up to 30% or higher, it may decide it's easier not to use an index when selecting this data. It may think, oh, I'll just do a table scan as opposed to using an index scan. It'll be more efficient. So having data skew 30% or higher can represent a performance impact. Now, to get this information, they actually had this query here looking at system tables, primarily at the PG statistic table, to be able to pull back the stats and give you a representation of the different data values for this column in this table. And they even have one where they show you what to modify to be able to look at those data points that represent 30% or more of a particular column's values. So this could be highly beneficial to look at to find where you have data skew in your database. But of course the question comes, well, how to handle it? And they have an excellent answer for this. So because Postgres may not use the index on values that are highly skewed or represent a significant portion of the table, you could always use a partial index. So add an additional index to the one that already exists, but specify that individual data that was skewed, and then the query will use this index to be able to efficiently pull out the data. But doing a partial index is a great way to still use an index when querying this type of data. Definitely check out this blog post if you want to learn more. Next piece of content, PGDAY Belgium 2023 Reflections. This is from cybertech-postgresql.com. Now, we don't normally cover these types of posts that reflect things that happened at a conference, but he does include his slides and his video, and that's what I found particularly interesting because it was a really good look at all the different monitoring tools that are available. So he talked about professional PostgreSQL monitoring made easy. So I really liked his presentation that he gave here. Now he did talk a lot about PGWatch 2, which is produced by Cybertech, but still he covers a lot of the different monitoring tools for Postgres in the community. So I definitely encourage you to check out this post as well as, of course, his monitoring presentation. Next piece of content, holy sheet, remote access CSV files from Postgres. This is from crunchydata.com, and he's talking about a scenario where you want to pull some remote data into Postgres and it's located as a CSV file in the cloud. And basically he's using Google Sheets for that purpose. And there's actually a command you can use to be able to pull down that CSV file. So he's just using curl here with a particular URL to pull down that information. So how do you get this in Postgres? The first option he's suggesting is copy from a program. And that program that you copy from is basically the curl command that can pull down the information. So you do copy to the table that you've pre-designed from program, put in quotes the program or command you want to run to pull down the data. And he's specifying CSV with a header and a UTF-8 encoding. And then that loads the data. Now the disadvantage of this is that you do need super user privileges to be able to run copy from program. So that's a disadvantage of this, but it works great. The next option he talks about is using the HTTP extension, and with that you can use the HTTP get function and specify the URL, and it will pull the data down. Unfortunately, it pulls it down as one big string, but he wants it as, of course, 22 rows of data. So there's a whole process of going through to separate the data out into columns and rows. So it's definitely not the cleanest thing to do, but it is possible. The next option is actually using PL Python. And of course, when you're talking about a programming language, it's definitely much easier to pull down data and then manipulate it at that point. So he has some code on how to do that here. And then the last option he says is remote access with a foreign data wrapper. And specifically, he's using the OGR foreign data wrapper, which I think is predominantly used for geospatial systems, but apparently it can pull down CSV files and allow you to load them into Postgres. So he describes how to do that here. So if you're interested in learning more about how to do that, definitely check out this blog post. Next piece of content, the PostgreSQL documentation and the limitations of community. This is from arhas.blogspot.com, and he's talking about the state of the Postgres documentation. And he says it exists the way it is now basically because it's the developers of Postgres, people who are actually doing the Postgres development, that writes the documentation. So when they add a new feature, they add the accompanying documentation in the same repository as the source code. So as a result, the documentation is very accurate. All the options tend to be well documented. And I would argue the documentation of Postgres is more like a comprehensive reference manual. So for that reason, it may be a little bit difficult to wrap your head around certain concepts. Or when you're first coming to Postgres, there's not a easy ramp towards understanding it. Basically, they give you the raw reference manual when learning Postgres. But he says that's the basic nature of how they do their documentation. And the problem is, even though someone proposes some changes, that's very hard to actually get those changes through because it's kind of always been done this way. So there's a bit of inertial resistance to it. But he says there's not necessarily anything wrong with that. It's just the way it is. But I did find it interesting to read this and think about it. So I definitely welcome you to check out this blog post as well. Next piece of content, use hot so cluster won't rot in PostgreSQL. This is from cybertech-postgresql.com. And he's talking about cluster primarily. And what cluster does is it enables you to rearrange your physical data pages on the table to match that of an existing index. So by default, an index is definitely an ordered structure, but when you query and an index is used, it then gives you a pointer to the different rows. Now, those may be located in entirely different data blocks, so pulling back the data may actually take a bit of time. The most efficient way to do it is if you actually order the physical pages on the heap or the actual table to that of the index. And that's what cluster does for you. Now, the disadvantage of cluster is that you can only cluster the data once to one index. So if you have 5 indexes, you can only pick one index that it will match. You can't, of course, do all 5 indexes. The other problem, and I would argue the bigger one, is that it needs access exclusive to do its work. What that means is the table will be locked for all reads and writes. So it's essentially like doing a vacuum full. So for that reason, I've maybe once used cluster. I hardly ever use it because of that disadvantage. And he also mentions here, it takes twice the amount of disk space because you're rewriting the whole table. But what he mentions here is that if you have a table and you can get some minor performance benefit by arranging it by cluster, if all you're doing is updates that are heap-only tuple updates, basically you're only updating the non-indexed columns, your table will remain clustered because the rows aren't being moved around. So if you have active inserts going, your cluster will eventually fall apart. It will become out of alignment with it. If you have updates that are not heap-only tuple updates, like indexes are being updated, your cluster again will fall out of order. That's another reason why I don't typically use it, is because you have to keep reclustering it, and it's incredibly expensive blocking reads and writes if you need to do that. But if all you have is heap-only tuple updates, and I believe deletes as well, the clustered order maintains itself. So this is a specific set of conditions that you may find a use case for. But again, in my experience, I haven't used cluster all that much because of so many of the disadvantages. And this post also goes into actually setting this up and experimenting with it and showing you some results. And the other important thing he mentions, if you're going to try doing this to actually get the heap-only tuple updates, you need to have the right fill factor. Like make sure the table's not fully full. It has some space to be able to do those heap-only tuple updates. And he has a table where he analyzed different fill factors for it as well. As I was reading this post, the other thing I would consider with regard to this is another way to get your data in physical alignment is actually using a covered index. Now, they didn't mention covered index, but basically this is where you're putting a data payload on the index itself. So that gives you an index-only scan as well as has the data right there in the index. Now, there's of course disadvantages with that, but that's another tact I would potentially take if physical co-location of the data is important to you. But definitely check out this blog post if you're interested, as well as this week's 5 Minutes of Postgres by pganalyze.com, where they talk about how to use hot updates in Postgres to make cluster work better. So you can check this blog post out as well. Next piece of content, the do's and don'ts of Postgres high availability, part 1, great expectations. This is from enterprisedb.com. And they're talking about when you're wanting to set up a highly available system, number one thing you need to think about is expectations. And with regard to that, they're talking about things like RPO, which is the recovery point objective, and RTO, which is the recovery time objective. So as they paraphrase here, what's the acceptable amount of lost data with RPO, and then what's the acceptable amount of downtime with regard to RTO? And he says in order to reduce RPO or keep it as low as possible, you would want to use synchronous replicas. So not just asynchronous replicas, but really synchronous ones. And ideally have more than one and require a quorum. Like in this example, he's using 3 replicas, but any 2 may be available for doing that synchronous write. Because what happens is synchronous means if a write fails on too many replicas, it doesn't even get written to the primary. So that's definitely important to be cautious of when setting up synchronous replication. In addition, he's talking about streaming the wall as well for backups. In terms of lowering the RTO, they're mentioning being able to get a old primary back up and being a replica as quickly as possible is basically using the PG rewind utility. And to do that, you need to make sure you have wall log hints set as true and full page writes to be on. And of course, they also recommend enabling PG checksums as well. And their last recommendation is using replication slots. And of course, they do recommend setting a max slot wall keep size, because if you don't set this, it's possible to run out of disk space on your primary if you have an orphan replication slot. But with this set, it'll go up to 100 gigabytes. But if you want to learn more about high availability settings, you can definitely check out this blog post. Next piece of content, pgBackRest file bundling and block incremental backup. This is from crunchydata.com. So these are 2 new features that have been added to pgBackRest, the file bundling and block incremental backup. So if you're interested in learning about that, you can definitely check out this blog post. Next piece of content, build hypothetical indexes in Amazon RDS for PostgreSQL with HypoPG. And this is from aws.amazon.com. And they're talking about the HypoPG extension, which enables you to create a hypothetical index. Now, it doesn't actually allow you to do actual queries, but allows you to explain a query you want to do, and then the planner can take into account this hypothetical index to see what impact it would have. So it's a way to quickly iterate and discover what the best index are for a particular table. But if you want to learn how to use it, you can definitely check out this blog post. Next piece of content, overview of ICU collation settings, part 2. This is from peter.eisentraut.org. So if you want to deep dive into more ICU collation settings, you can definitely check out this blog post. Next piece of content, managing data in PostgreSQL, learning PostgreSQL with Grant. This is from redgate.com. And Grant is covering inserts, updates, deletes, as well as the returning clause and merge, which is in Postgres 15. So if you want to learn about data changes in Postgres, definitely check out this blog post. Next piece of content, there was another episode of Postgres FM this week. This one was on extensions. It covers what they are, how they affect your decisions around Postgres, and some things to keep in mind while using them. You can listen to the episode here or check out their YouTube video here. Next piece of content, the PostgreSQL Person of the Week is Oleksii Vasyliev. If you're interested in learning more about Oleksii and his contributions to Postgres, definitely check out this blog post. And the last piece of content, we did have another episode of the Rubber Duck Dev Show this past Thursday afternoon. This one was on the future of Dragon Ruby with Amir Rajan. So Dragon Ruby is actually a game development toolkit where you can use Ruby to write games. If this is something that's of interest to you, we welcome you to check out our show. That does it for this episode of Scaling Postgres. You can get links to all the content mentioned in the show notes. Be sure to head over to scalingpostgres.com where you can sign up to receive weekly notifications of each episode. Or you can subscribe via YouTube or iTunes. Thanks.